Scientists have studied Jupiter for over 400 years. They thought they had a pretty good handle on it. They were wrong. Here's something most people don't know. Jupiter is not a gas giant. That's the label we gave it in school, and it stuck. But when NASA's Juno spacecraft got close enough to actually measure what's inside, and when the James Webb Space Telescope started reading Jupiter's atmosphere in ways we never could before, the picture that came back was something nobody had prepared for. A world that shouldn't work the way it does. A world with a core that's dissolving. A world where single lightning bolts carry the energy of nuclear weapons. And a world whose storms don't just sit on the surface, they punch down hundreds of miles into the planet like roots of a tree you can't see. Stick with us, because by the end of this, you're going to look at that bright dot in the night sky very differently. And if you want more videos like this, subscribe to Space Aquarius. We cover the science that doesn't make the evening news. Let's start with the thing that should have been simple. Does Jupiter have a core? For decades, scientists had two theories. Either Jupiter had a dense, solid, rocky core at its center, formed the same way Earth did, with heavy material sinking to the middle as the planet cooled. Or it had no core at all, just layers of gas getting denser and denser all the way down. Both theories made sense. Both fit the math. Here's the problem. Both were wrong. When Juno started measuring Jupiter's gravitational field from the inside out, something no spacecraft had ever done before, the data came back strange. The core wasn't solid. It wasn't absent either. Scientists are now calling it a fuzzy core. That's the actual scientific term. Fuzzy. What it means is this. The heavy elements at Jupiter's center, the rock, the metal, the ice, are not sitting in a neat, compact ball. They are spread out across a region that may cover half of Jupiter's entire radius, slowly dissolving, gradually blending into the liquid hydrogen above them like a sugar cube dropped into warm water. This shouldn't be possible. Gravity is supposed to pull the heavy stuff down and keep it there. That's basic physics. That's how every planet formation model works. But Jupiter's fuzzy core has been sitting in this impossible state for over 4 billion years. And when scientists looked at Saturn using data from the Cassini mission, they found the exact same thing. Two gas giants, both with fuzzy cores. That's not a coincidence. That's not a random accident. That's telling us something fundamental about how giant planets form something our models have been getting wrong this entire time. Now here's where it gets stranger. Jupiter is not a gas giant. It's a liquid planet, specifically a liquid metal planet. Here's what that actually means, because it sounds like science fiction, but it's completely real. When you go deep enough into Jupiter, past those swirling cloud bands we see in photographs, the pressure from the planet's own gravity becomes so extreme that hydrogen gas stops behaving like a gas. About 600 miles down, the hydrogen compresses into a liquid, not like water. This is hydrogen staying liquid at temperatures over 10,000 degrees Fahrenheit. Because the pressure is so intense, it has nowhere else to go. That creates the largest ocean in the solar system. Not water, liquid hydrogen, stretching down for thousands of miles. Keep going deeper, and it gets stranger still. The pressure becomes so extreme that the electrons get stripped away from the hydrogen atoms. The hydrogen starts conducting electricity like a metal. Liquid metallic hydrogen. It makes up somewhere between 75 and 90% of Jupiter's total mass. Think about what that means. Jupiter. The planet you learned about in 4th grade is essentially a ball of liquid metal the size of 11 Earths, spinning once every 10 hours, generating a magnetic field so powerful it creates radiation belts that would kill an unprotected astronaut in minutes. And that magnetic field? It's one of the most bizarre things in the entire solar system. Jupiter's magnetic field is 16 to 54 times more powerful than Earth's, but it's not organized the way ours is. Earth's magnetic field is relatively clean 2 poles, north and south, predictable enough that a compass works. Jupiter's field is lopsided. It has strange patches of intense magnetism concentrated in certain regions. It has multiple south poles. It shifts and warps in ways that don't match any model scientists have built. Juno's instruments confirm this directly. The field isn't generated uniformly from the core. It appears to be influenced by material above the core, by those layers of liquid metallic hydrogen churning and spinning at different rates. Nobody fully understands why it behaves this way, and that matters more than it might seem, because Jupiter's magnetic field is what creates the radiation environment around the planet. That radiation is what makes missions to Europa, Jupiter's moon with a liquid ocean beneath its ice, so incredibly difficult to plan. Every spacecraft we send has to be hardened against a magnetic field we still can't fully predict. We're trying to navigate a neighborhood we don't completely understand yet. Now let's talk about the weather. Because what Juno and James Webb Space Telescope revealed about Jupiter's atmosphere is the kind of thing that makes meteorologists quietly set down their coffee. You know the Great Red Spot, that giant storm that's been raging on Jupiter for over 300 years. It's wider than the entire Earth. Most people assume it's a surface feature, a weather pattern sitting on top of the clouds. It isn't. Juno's gravity measurements revealed that the Great Red Spot extends over 200 miles deep into Jupiter's atmosphere. 200 miles. The storm isn't sitting on Jupiter. It's embedded in it like a nail driven into wood, with most of the nail hidden below the surface. And the regular cloud bands, those beautiful stripes of orange and white, those jet streams, reach down 2,000 miles below the cloud tops. 2,000 miles of organized high-speed wind. For comparison, Earth's atmosphere, the entire thing, from the ground to where space begins, is roughly 60 miles thick. Jupiter's weather system is 33 times deeper than our entire sky. But here's the discovery that genuinely shocked researchers. In March 2026, a study published in the journal AGU Advances confirmed something Juno had been hinting at for years. Jupiter's lightning is 100 to 10,000 times more energetic than lightning on Earth. Let that land for a second. A single bolt of lightning on Earth releases about 1 billion joules of energy. That's already an almost incomprehensible amount of power. The most extreme bolts of Jovian lightning carry 10 trillion joules. That's equivalent to 2,400 tons of TNT. About 1/6 the power of the atomic bomb dropped on Hiroshima. And based on the flash rates Juno observed, the storms on Jupiter can unleash the force of multiple nuclear weapons every single minute. Every minute. Planetary scientist Michael Wong at UC Berkeley, one of the study's authors, described it this way. He said, "Trying to measure the full energy of one of these bolts is like seeing the Loch Ness Monster break the surface. You can measure what you see, but you can only guess at how big the whole thing really is, because those bolts don't just release energy as light. They release it as heat, sound, radio waves, and chemical reactions simultaneously. The number we measured may actually be an underestimate. And here's why that matters beyond just being terrifying. Lightning is one of the primary ways complex chemistry gets started. It breaks apart molecules and forces them to recombine in new ways. On early Earth, scientists believe lightning played a role in creating the first organic molecules, the building blocks of life. Jupiter's lightning is doing that same chemistry, right now, at a scale that dwarfs anything on our planet. Whether that chemistry leads anywhere, whether it produces anything meaningful in Jupiter's atmosphere, we don't know yet. But the James Webb Space Telescope is watching, and it's reading Jupiter's chemical fingerprints in ways Juno's instruments never could. Here's the thing that ties all of this together. Jupiter is the oldest planet in our solar system. It formed first pulling in the most material, growing the fastest, shaping the gravitational environment that every other planet, including Earth, formed inside of. If we don't understand Jupiter, we don't understand how we got here. The fuzzy core rewrites planet formation models. The liquid metal interior explains a magnetic field we still can't fully predict. The storms that go miles deep tell us the atmosphere is not a thin shell, it's a deep, structured, violent system that has been running continuously for billions of years. And the lightning, those nuclear-scale bolts firing every minute, may be driving chemistry that mirrors the origin of life itself. Jupiter isn't just the biggest planet in our solar system, it's the one that holds the most answers. And the more we look, the more we realize how many questions we haven't even thought to ask yet. If this video changed how you think about Jupiter, subscribe to Space Aquarius. Leave a comment below telling us which discovery hit hardest, and share this with someone who thinks they already know everything about our solar system, because they don't. None of us do.